Wake up, Toni. We're all awake. I bet you're still sleeping in. We already did 98 because we kind of forgot about you, but I figured I'd turn this on for number 102 and hopefully give you an idea as to, hopefully, if you had any problems, where you went wrong. So we're working on number 102, guys, and I'm not even going to try to name these things, but they give us a reaction with some crazy stuff. It's combustion. Oh, it's, no. You're still allowed to talk back there. It's okay. Tori didn't come because you're not here, Toni. She missed you. She couldn't survive without you. And as strange as it may sound, I was thinking about your hair. I hope you didn't get it too wet yesterday. Okay. If 15 grams of this, oh boy, this is the problem, and 10 grams of this, and 5 grams of this are reacted. Do you hear it? Shh. You hear them? Ding, 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 ding. You are given amounts of more than one reactant. This is a limiting reagent problem. That is the key. When you're given masses or whatever amounts of more than one reactant, it's limiting reagent. What mass of a silicate can be produced assuming 100% yield? Yes.
It's supposed to be 5 grams of IH3 and 10.
Thank you. That's important. Thank you for telling me that before I went so far and calculated with all the wrong numbers.
And then we had to tell you were wrong.
What's that?
Having fun.
Yeah, I would have been really mad had I done that whole calculation with I would have been mad at you, not even at myself, but mad at you for not telling me. You're all sitting there watching me do the wrong calculation. That would have been frustrating. Okay, so first thing you need to think about is that we work in the language of moles. So we need to get each of these reactants to moles. So hopefully you all did that, right? You took your 15 grams of the C3H6 and got it to moles. And you can see that I got the moles on my paper there. 1 mole is 4209, and you should get 0.0356371 moles of the C3H6. And then I found moles of nitrogen, or ammonia, using my 5 grams of ammonia. Ammonia is 1704, and you get 0.2934272 moles of ammonia. And then you did your oxygen. And 1 mole of oxygen is 32 grams, and 0.3125 moles of oxygen. Anybody have a problem with that step?
I just have a question.
Yes?
When you're finding the formula mass of those, why don't you add in the coefficient?
Because the formula mass is always for 1 mole.
Okay.
It's not for 5 moles or 4 moles or 3 moles. It's for 1 mole. So you don't care about the coefficients.
But
Yes?
Shouldn't the first number be 0.356, not 0?
Not 0.
Yep, that's what I have on my paper. Thank you. I just miscopied it.
Okay.
Testify, it's on the paper. You see it.
I don't have mine. It's got coffee all over it.
Oh, here. Okay.
Thank you.
No, I don't have one. I made extras. Okay, any other questions on that first thing? Remember, Joe, I said you never use the coefficients unless you're doing a mole-mole problem. All right, so that's why. Okay, so after, this is a tricky one because now there's 3 reactants we have to compare. But you can only compare 2 at a time. So my next step after I find moles is to compare, I guess it's the second step, compare what I have to what find my needs. Then compare them. So it doesn't matter who we pick to start with. By convention, I usually just start with this first thing in the equation and say, all right, if I have this much C3H6, how much ammonia am I going to need? Right? And see who's limiting with them. That's what I do. So I think I started that way here. I don't know. But usually I do. Okay? Yep. So if I have I did it again. 3, 5, 6, 3, 7, 9, 1. moles of C3H6. That's what I have, right? Of the C3H6, that's how much I have from up here. I'm going to see how much NH3 I need to react with all of that, just like last time when we did that problem. So I do a mole-mole between those reactants to see how much of that I need. Now, according to the equation, for every 2 moles of C3H6, I need 2 moles of NH3. So that means I will need 0.356371 moles of NH3 needed. Now, I'm not going to write it down every time, but now you compare. Do you have enough NH3? This is how much you need. Go back up here to see how much we have. Uh-oh. We only have 0.29 blah, blah, blah moles of NH3. So we don't have enough NH3. We need more than we have. We only have, what, 0.29? So therefore, between the two of these, between these two guys, these two, who's limiting? NH3 is your limiting reagent between these two. Okay? So I know this. What I know right now is that this is in excess. But I still don't know who's limiting between the NH3 and the O2. So now I need to do a mole-mole. What's that? I need to do another mole-mole between them. Normally there's only 2 reactants. This is just a little more complicated because there's 3. Now we need to do a mole-mole between them to figure out who's going to run out first. So again, I'll start with the NH3. I have 0.293472 moles of NH3. And according to the equation, for every 2 moles of NH3, I need 3 moles of O2. So I need 0.4401 yada yada moles of O2 to react with all my NH3. Do I have enough? No, I only had 0.3 moles of O2. So I don't have enough O2. So what does that tell us? Right, this is also, the NH3 is also in excess, and oxygen is your limiting reagent. Now we know who the limiting reagent is. We can use the moles that we have of the limiting reagent to find the moles of what they ask us for. So step, I don't know, is anybody counting? Step whatever. 3? Okay. Yeah, it's a lot. Step 3, use the moles you have, that's this one, of limiting reagent to find moles of product. So 0.3125 moles of something, something, something oxygen. According to the equation, for every 3 moles of oxygen, I generate 2 moles of the C3H3N. That will give me the moles of the C3H3N, but they wanted mass, right? So then I'll just keep going and convert that to mass. 1 mole of the C3H3N is 53.07 grams. And my final answer, when all is said and done, is 11.1 grams. Questions?
Yes.
Yep.
How did you know the O was limiting reagent over NH3? Like, that's where I got a little...
I did a mole-mole between the NH3 and the O. Right here. So I took my moles of NH3 that I have and figured out how many moles of oxygen I would need. Just
so
like
there was enough oxygen that NH3 would have been
correct.
limiting, and since there's less O.
We don't have enough oxygen than what we need to react with all the NH3.
Okay, I got it.
Yes?
So NH3 and oxygen, are they both excess? Or
No. NH3 and the first thing are both in excess. We don't have enough oxygen. Look at, this is how much oxygen we need. This is how much oxygen we have. We have less than what we need. If you have less than what you need, that means you don't have enough, which means you're limiting. You're going to run out before the NH3 does.
okay, and NH3 was the limiting with the other.
Yeah, but you don't care you care about who's the limiting overall, not who's, so you don't have 2 limiting reagents. You only have 1.
Okay.
Okay? It's unusual because we had to do 2 limiting reagent calculations because there were 3 reactants that they gave us amounts on. But you can only do 2 at a time. So I took 2 and compared them, and then whoever was limiting between those 2, I compared that with the next one. And then whoever's limiting between those 2 is the limiting winner or loser, whatever way you want to look at it. Okay?